Good morning, class. Today we're going to continue with our unit on logarithms and exponential function. And today we're going to start out by explaining what the change of base formula is. Comes in real handy when you don't have a calculator. Um, Change of base formula converts a log into a numerical answer. So if a logarithm does not come out, what we call evenly, you can use this change of base formula. Um, you can put it into the calculator. Um, what happens is you are given a log with a base and a number, and we can use log base, whatever we want to use, and we can also use natural log. So the example would be to take the log of the big number divided by the log of the base. So log of the big number divided by the log of the base. Okay, so it looks like this. And we can also do the same with natural log. It doesn't matter which one you use, they both will give you the same answer. So let's do an example. I want to evaluate log base 5 of 18. So I'm going to take log of 18 divided by log of 5. And I can write it as this, or I can do natural log. Either way. So if we type that into a calculator, it's going to give us a decimal answer. The log is known as a common log, and the ln is natural log. So write as a common logarithm and a natural logarithm log base 4 of x. So the common log would be log of x divided by log of 4. The natural log would be natural log of x divided by natural log of 4. So that's a little bit about change of base formula. It's when you can't use those properties that we saw a couple of sections ago. Here are going to be 3 more logarithm properties. These are going to teach us how to expand and condense logarithms. So in example number 1, or property number 1, we have the log base A of some number times another. Some number B or some expression B times another expression. We can split that up into 2 logs if we just take the log of one of those and add it to the log of the other. So log B plus the log base A of C. So multiplication can be expanded by addition. Rule number 2, we have log base A of some number divided by another number. So division can be expanded by subtraction. we can convert that to log base A B minus log base A C. So subtraction undoes or reverses division. And the third and final property is when we have an exponent. We need to bring down that exponent or expand it. The exponent comes out in front of the log. An example of that would be, remember, natural log of E is the same thing as log base E of E. Okay. We set that equal to X and convert. And X is 5. Well, we could do that easily by just bringing that out in front. Get the same thing. Quick review of rational exponents. Probably haven't seen this in a while. If we have a fraction as an exponent, we can rewrite that in radical form by taking the denominator and making it our index and leaving the numerator as an exponent under the radical. One of our exponent rules was power to a power. That's two exponents separated by a parenthesis. We multiply those exponents. Here's another example. We have x to the 1/2. The 2 becomes our index. To make that a square root, we just never write the 2 because it's known, the radical is known to be a square. The exponent 1 stays there. We just never write 1 as an exponent. Again, if you have power to a power, two exponents separated by a parenthesis, you multiply. So now we're going to put all these properties into a problem and work them out. Here I have log 2x to the third, y to the fourth. Remember, if we don't have a base, we assume that it's 10. That's one of those things that's just understood. We never write them. So I've got some multiplication going on here, and I've got some exponents that I need to use my three properties to expand this logarithm. So remember, I can undo multiplication by adding, and I can get rid of the exponents by bringing it out front. So let's undo the multiplication. When we do that, the 2 can go by itself with the log, the x to the third, and the y to the fourth. So the second step would be log 2 plus log x to the third plus log y to the fourth. The last thing we want to do is take care of the exponents. Bring the exponents out in front of the log therewith. So the 3 comes out front here, the 4 comes out front here. That's as far as we can go with this example. This is called expanding the logarithm. Next example. We have a natural log of radical x plus 5 divided by y squared. So we have an exponent, we have division going on, we have a radical that we need to get rid of by making an exponent. So first things first, undo to the division by subtracting. So we're going to split this up, make it look a little neater. We'll do that by subtracting to get rid of the division. I need to get rid of that radical by making an exponent. This is really a square root, and this is really to the exponent of 1. So my exponent should be 1/2. So that'll get rid of the radical. Then all I have to do is move my exponents out in front of the log. So I'll have 1/2 natural log of x plus 5 minus 2 natural log y. Next example. I've got division going on. I've got a cube root, and I've got some exponents that I need to take care of. First step, we're going to undo the division by subtracting. So I'll take natural log x squared minus natural log cube root of x cubed plus 2. Next, I'm going to take care of this cube root. This cube root right here needs to go away. So that's going to make my exponent 1/3. In the next step, I'm going to bring my exponents out front of the logs. All right, number 4. We have a radical over a whole fraction with exponents. So the first thing that I'm going to need to do is get rid of this radical by coming up with exponent for this whole thing. That is a square root, so my exponent will be 1/2. So the 1/2 goes out in front of as an exponent, behind each one of those expressions or terms. I can now get rid of the division looks like they're multiplying those exponents. 3 times 1/2 is 3/2. 1/2 of 4 is 2. So they simplified that. And now they're going to let me do the division by subtracting those 2 natural logs. And I'll bring my exponents out in front. So my final answer would be 3/2 natural log x minus 2 natural log y. Now we're going to go the other way. We're going to condense the logarithm. We're going to go in the opposite direction. We were expanding. Now we're going to condense. So our first move, we're first going to move the coefficients, and then we're going to combine. So we need to take care of the 2, the 3, and the 1/2. Those are going to go in the opposite direction and become exponents. They'll become the exponents. Notice the 1/2 goes to a square root. And the 2's here, the 1's here. Now I can get rid of the subtraction and the addition. It's best to go left to right and do whichever one comes first. So I'll take care of the subtraction by dividing. Take care of the subtraction by making a fraction. I'll take care of the addition by doing a multiplication. Notice that it stays on top with the x squared. So the addition becomes a multiplication. Next one, I need to take care of my coefficients out front by making them exponents. I now have 2x to the 4th all raised to the 5/2 power. So we need to figure out what is 2 to the 5/2 power and what is 4 times 5/2. Two to the 5/2 power works out to be the square root of 32. And here's how we get that. Remember, the 2 is going to be our index. We've got a 2 underneath raised to the 5 power. 2 to the 5th is 32. That's 2 times itself 5 times. And 4 times 5 divided by 2 is 10. Okay. Over here, we've got 3 times 2/3 will give us 2 as an exponent. And then all we need to do is take care of the subtraction by dividing those two. The left one divided by the right one. And that gets it back down to 1 log. Next example. Notice that I have 1/3 out in front of everything that's in a pair of parentheses. So that's the first thing I'm going to have to take care of. Looks like we went ahead and moved the exponents to 2 and 4, and now we'll take care of what's inside the parentheses. Natural log of x squared divided by natural log of y to the fourth. So that's a division. And if it's another division, it stays on the bottom. If this were an addition, we would multiply and the z plus 2 would stay on top. But since it's a subtraction, we're dividing, so z plus 2 goes to the bottom. And now the 1/3 becomes a cube root over everything because all of this was originally in a set of parentheses multiplied by that 1/3. So the cube root is over all of it. All right, so that concludes today's lessons. Stay on the Zoom if you have any questions or email me with your questions. Have a good day.